Okay, here we go. So today is, what did I say was? Rates. So we're doing rates. Let's just jump in. Page 68 is on the side. It's very tiny. I don't know if you can read it, but I'll read it for you. Example 1. Diet Cola was on sale last week. It cost 10 for every four packs of Diet Cola. How much do 2 packs of Diet Cola cost, and how much does one? So here we have, remember, a rate is a ratio. It just has a fancy name. Instead of ratio, it's called a rate. And remember, a rate is something that you're comparing that is from two different categories. In this case, we're comparing money and Diet Cola. So as a rate, you're going to write it as a fraction. That's okay. And I'm having problems with my pen, but let's see if I can fix this. And here we go. So let's write it. $10. I like to put my money on top. It doesn't matter. You will get a different perspective if you put the money at the bottom. Okay. So and here we go. 4 packs. So that's my rate. Okay. Now write rate at the bottom here. A unit rate, okay, which is also rate, again, just another fancy way of saying something here. A unit rate is when you compare something to one item. So from 4 packs, we're going to go to 1 pack. Okay, and this is a unit rate because we're comparing something, money in this case, to a single item, or in this case, 1 pack. So again, to go from rate to unit rate, this is your setup. And think about the relationship here. How do 4 packs become 1 pack? It's divided by 4, and I must apply the same on the top. So 10 divided by 4, and it's going to cost you $2.50 per pack. Now, with this information, my unit rate, I can find out anything I want, literally. Okay, so question is, first question A. Actually, I just did B. So this is the answer to B. How much does 1 pack of Diet Cola cost? Well, to find that, I actually found the unit rate. So 1 pack is $2.50. So how would I find 2 packs? Well, 2 packs is easy enough, okay, that you could just double it to find your answer, but let me do it the long way. So here's $2.50 for 1 pack, and you want to find how much 2 packs is. Well, you're going to set up a proportion. And like I said, this was easy enough that you can just do it mentally, but if you were to do it like this, from 1 pack to 2 packs, the growth was times 2, and the top has to be times 2, giving you a total of $5 per 2 pack. So I did this backwards. I ended up finding the unit rate first, and then I found what 2 packs would cost. Okay, so that was the top 2 questions. Let's go to a clear page, and Tegan went to Gamer Realm to buy new video games. Where did they find these names? Okay, anyways, they were having a sale. So here we go, and the sale was that it was $65 for 4 games. That's not that bad. So there's your rate. Okay, you're comparing 2 different things, 2 different categories, money to games. And let's see, what else? He said he bought 3 games for himself and 1 game for his friends. Okay, Diego, but Tegan does not know how much Diego owes him for 1 game. Okay, what is the unit price? Okay, so again, you start with the rate, and you're going to go to unit rate. To find the unit rate, it means comparing this to 1 single item, in this case 1 single game. Alright, so from 4 to 1 is divide by 4. 4 divided by 4 gives you 1, so you got to do the same thing on top. 65 divided by 4 is, I have no idea. 2 is, let's see, 60. 15. Why don't I just divide because I'm to 15. Okay, 65 divided by 4, it's 1 over here, 4 down. 25, bring the 5 down, and you go 6. Sorry, 4 times 6 is 24. And 1 is left over. I can continue this, okay, because it's money. So let's continue. Add a decimal. Bring my first 0 down. And 4 goes into 10 2 times. And that's an 8. 2 left over. I'm going to bring another 0 down. Oh, look at that. Nice and pretty. And 4 goes into 20 5 times. So each game is $16.25. Okay, and that's our unit rate. Okay. Next page, and let's go to the next page on this one. And we're doing 69. Page 69 is 4 football fans took turn driving the distance from New York to Oklahoma to see a big game. Each driver set the cruise control during his leg of the trip, enabling him to travel at a constant speed. Okay. The men changed drivers each time they stopped for gas and recorded driving times and distance in the table below. What do you mean they changed drivers? Alright, so Andre drove 208 miles in 4 hours, Matteo 456 in 8, and Janae 306, and Grayson 265 in 5 hours. What two quantities are being compared here? Well, so A, it's easy enough. Quantities that we're comparing distance with miles. Okay, so A, we're comparing distance over miles, okay, over hours, I'm sorry, distance over hours. Okay, B, what is the ratio of the two quantities of Andre's car? Andre's car we're comparing is 208 miles to 4 hours. Okay, what's his rate? Oh, okay, what's the ratio? What's the rate? What is the ratio of the two quantities? I think it's the same answer for A and B. Okay, for B in Andre's case. So C, answer the same two questions in part B for the other three drivers. So what's Mateo's rate? 456 over 8. Janae's 300 over 6. And Grayson's is 265 over 5. For each driver, circle the unit rate and put a box around the rate unit. What? Alright, okay, so let's find the unit rate for each of the drivers, okay, which is what I think the last question is talking about here, okay, on part D. Alright, so that stops from going up and down. Okay, stop. Alright, so 208, and we're doing Andre, by the way. 208 miles in 4 hours. The unit rate would be how much he drives in 1 hour. So divide by 4, and divide by 4, and 208 divided by 4, it's, wait, 4 goes into 5, of course 4 goes into 25, 52, so he drove 52 miles in 1 hour. Matteo was 456 in 8 hours. Okay, to change this to a unit rate, the denominator here is going to change to 1 hour instead of 8. So it's divided by 8. The top is divided by 8. 8 goes into 45 5 times, which is and then 57 miles an hour. Okay, and then we have Janae, which is 300 over 6. I should be writing the units, okay, my apologies. 300 miles over 6 hours. When it changes to unit rate, which is 1 hour, divided by 6, and top divided by 6, which gives you 50 miles. And finally, the last guy, Grayson here, drove 265 miles in 5 hours, which means that in 1 hour he was averaging, divided by 5, let's see, it goes 25.53 if I'm not mistaken. Alright, so you got 52, 57, 53, 50. By having it in unit rate, you can tell who went more in a single hour. Okay. Alright, so that's that. Let's see what else there is on that page. There's nothing else, so we're going to page 59. A publishing company is looking for new employees to type novels that will soon be published. The publishing company wants to find someone who can type at least 45 words per minute. So here's our ratio. Okay, 45 words in 1 minute. Good. They gave it to us as a unit rate, which is even better. Now Dominic discovers she can type at a constant rate of 704 words. So this is what the company needs. Somebody who can type 45 words in 1 minute. Dominic, I think it's a she can type 704 words in 16 minutes. Okay. And 16 minutes. She wants to know if she's good enough or fast enough, I'm sorry, to apply for the job. Well, we don't know how many what do you call her unit rate. We don't know how fast she types in 1 minute. She knows how fast she can type in 16 minutes, but let's see if she qualifies. So in 1 minute, which is what we're doing, we're finding the unit rate. This is divided by 16. Okay, and the top obviously has to be divided by 16 as well. Okay, so, and I am going to cheat and look for a calculator because I don't want to divide. And 704 divided by 16. No, not my alarm clock. I need my calculator. No. And finally, calculator. Yay for iPhones. 704 divided by 16 will give you 44. So, 44 words per minute. So, can she apply for the job? She's going to have to practice a little bit more because she's just under. Okay, she can type 44 words per minute. Meanwhile, in order to apply for the job, you need to have your rate to be 45 words per minute. So maybe if she practices a little bit more, she can come back in a month or so and apply for the job. Okay, easy enough. 71, I think, is the next page. All right, so move. Scott family, blah, 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 is trying to save as much money. One way to cut back on the money is they spend finding details while grocery shopping. However, the Scott family needs help determine which store have the better deals. Okay, so at Grocery Mart, strawberries. Okay, so let's go Grocery Mart here. At Grocery Mart, strawberries are $2.99 for 2 pounds. That's not a bad deal at all. LBS. And where else? Baldwin. Baldwin is $3.99 for 3 pounds. $3.99, by the way. That's a 9 for 3 pounds. Okay, so basically the question is, where should they shop if they want to save money? Obviously, you want to go to the place where it's offering you the better deal per pound of strawberry. So you need to find the unit rate for each one. So let's see if I can squeeze that in here. So at this supermarket, the Grocery Mart supermarket, let's see how much 1 pound is. 1 pound, which are, why am I doing this? Let me squeeze. Okay. And let's do that. Okay, so 1 pound, 1 LBS, or pounds. To go from 2 to 1 is divide by 2, so obviously you got to divide the top by 2, okay? And $2.99 divided by 2, to be exact, is $1.49, 49.5, okay? But since we're talking about money, I guess you can round it to 150. Okay, because if you divide, you're going to get 1.495. Money is 2 decimal places. The 5 makes the 9 go 1 higher, so that's how I got 150. And let's see how much on the other side. $3.99 divided by 3, I'm sorry. $3.99. $3.99 dividido por 3 is 133. So here, on this side, okay, you're going to go 1 pound on this supermarket. Let's find out 1 pound strawberries. And if you did divide by 3 at the bottom, divide by 3 on top, you get 1.33. Alright, so where is it cheaper for the pound? This supermarket. 1 pound strawberries cost you 133, and 1 pound of strawberries and the other one costs 150. Okay, you needed to find the unit rate in order to compare. Okay. And there's one more question at the bottom of the page. Potatoes, same supermarket, Grocery and Baldwin. And so let's do this again. So at grocery, it's $2.85 for 5 pounds. And at the other supermarket is $4.20 for 7 pounds. Okay, so this is grocery and the bottom one is Baldwin. Okay, so again, you want to know which one's cheaper. It's very hard to compare or determine in this particular format where they have it as a rate. But if you change this to unit rate, so this is 1 pound, you're going to divide by 5 and you're going to divide the top by 5. Okay, and let's see what you're going to get. You're going to get that 1 pound of potatoes at Grocery Mart is 0.57 cents. Not bad. And at the Baldwin supermarket, you're going to take $4.20 and you're going to divide by 7. Okay, so this is going to become 1 pound as well. And from here to here is divided by 7, so I do the same thing at the top. And you get 0.60 or 60 cents. So in this particular case, as opposed to the strawberries, it's better off going to the Grocery Mart. Okay, different of 3 pennies. Might want to think about, depending on distance, is if it's worth going further down. If it's only a difference 3 cents, but that's another topic for another day. Okay, so anyways, so grocery had the cheaper one by 3 cents as far as the potatoes goes. Okay. And what is this? Is page 71, and I think next page 74. Ooh, there's a lot. Ooh, what do we have? Fractions over here. Yikes! All right, so Emmeline can type a constant rate of 1/4 of a page in 1 minute. What is the ratio of pages to minute? All right, so the ratio is 1/4 of a page to a minute. I don't know why they keep asking that same question. What is the ratio of pages? So how many? The ratio of pages. So question letter A was 1/4 of a page. The ratio is 2 1 minute. Okay, there's your ratio. Or if you put it as a fraction. Okay. Emmeline has to type a 5-page article, but only has 18 minutes until she reaches the deadline. Does she have enough time to type this article? Alright, so let's set it up. Now, if you write it as a fraction, you get 1/4, okay, over 1 minute. Okay, and then she's typing 5 pages. And we want to find the time at the bottom. Okay, it takes her 1/4 of a page for 1 minute. We want to know how long it's going to take her to do 5 pages. There's an easier way of doing it. Okay. The easier way for me, okay, would be to change this fraction to a decimal. Okay, so what I would have done is take that same rate, and because I don't like the way that looks over there, fraction over divided by, fraction over fraction, I would change that to 0.25 over 1 minute. Okay, and it takes her 0.25 pages, so 1/4 of a page takes her 1 minute. How long would it take her to type 5 pages? And there's a question mark here. Is a relationship there on top? What times 0.25 equals 5? And that you would use reverse. Okay, you divide 5 by 0.25. Okay, 5 divided by 0.25 gives you 20. So you multiply this by 20. 0.25 times 20, you get 5. So at the bottom would be times 20. And you get your answer of 20 minutes. Okay, so for 5 pages, okay, it would take her 20 minutes. Okay, can she have, so does she have enough time? No, because she only has 18 minutes. You could have drawn this, okay? If you understand, okay, another way of doing this is drawing, which actually shows, here's a page, okay? And let's divide this in quarters. 1, 2, 3, 4. Okay, so for her to type this section right here, it takes 1 minute. For her to type this section 1 minute, it takes 1 minute, another minute here, and another minute here. So to do one single page, it takes her how many? It takes her 4 minutes. Which is another thing you could have done here. You could have changed your ratio. Okay, I'm sorry. Yeah, you could have changed your ratio. But let's keep it this as it is right now. So one page takes her 4 minutes, and we have 5 pages, right? So 5 pages would take 5 times 4, which is 20 minutes. And you didn't have to set up a portion. So you had choices. Okay, so C, she had to take 7. She has to type 7-page article. Well, you know one page takes her 4 minutes, so 7 times 4, which would give you 28 minutes. Okay. Next one. Xavier can swim at a constant speed of 5/3 meters per second. Seriously, why do they give you weird numbers? 5/3 meters. Here's your ratio in 1 second. I personally don't like the way they gave it to you guys. And like I said, I would change this. Okay. I would even change that. Well, you know what? Let's leave it like that for now. But I would probably change it to a mixed number, or even change it to a decimal. But if you change it to a decimal, the problem you have when you change it to a decimal is you're going to get a decimal was, oh my God, what's the word I'm looking for? You're going to have to round because it's not going to be a terminating decimal. There you go. That's the word I'm looking for. Okay, you're going to get 1.6666 that goes on forever, and if you round it, it's going to be 167. So that might affect your answer for a little bit. So, what's the ratio of meters to seconds? The ratio is 5 over 3 meters in 1 second, or 1 2/3 meters for every second. That's how fast he can swim. B, he's trying to qualify. To qualify, he must complete a 100-meter race in 55 seconds. Will he able to do that? Well, let's see. We know this is the rate. So 5 over 3 meters in 1 second. Let's see how long it takes to swim 100 meters. Okay. Better yet, instead of doing it that way, let's do this a little bit different. Let's see how much or how far he can swim in 55 seconds. We know that it has to be 100 meters. Okay, so if we gave Xavier 55 seconds, how far would he go? And we know that whatever answer we get on top has to be 100 meters or less. Okay, so relationship here is 55 times 55, and we're going to multiply this times 55 as well on top. Okay, let me take that to the bottom. 5 over 3 times 55, and you can put that over 1, and you get 27 over 3. Well, let's simplify that by changing it to a mixed number. 275 divided by 3 means it can go in 91 times, okay, and and 2/3. So if we gave him 55 seconds, he would swim 91 and 2/3 meters. Okay. Will he be able to qualify? No. Okay. Why? Because he doesn't swim that distance in 55 seconds. He's a little bit too slow. Okay. You know that he's missing about 8 more meters. Alright. So that's one way of solving this, seeing how much he can swim in 55 seconds. Okay. No, there's another part. He's also attempting to qualify for the same meet in the 200-meter event. To qualify, Xavier would have to complete the race in 130 seconds. Alright, so let's copy the same thing. So we know that this is how much he can swim. 5 or 3 meters in 1 second. Okay, so easier way of doing this is if we gave him 130 seconds, okay, how far would he go? Well, it's time 130, and the top is times 130. So let me take that to the bottom here. 5 over 3 times 130. And if you multiply across, you're going to get that is, let's see, 5 times 0, 0. 15 goes 1, 650 over 3. Okay, and 650 divided by 3 is is 216, and there's a little bit 216 and 2/3. Okay, so if we gave him 130 seconds, okay, 2 minutes and 10 seconds, and say, go ahead, swim, let's see how far, he would actually swim 216 meters and 2/3. 216 and 2/3 of a meter, which is much more than necessary. Okay, so he would definitely qualify for the race. Okay, so because he's able to swim 200 meters, which is the minimum. He actually can swim much more than 200 meters in 130 seconds. Okay? And I forget what page this is. 74. We have one more. Okay, it wasn't that bad. And 75, I'm assuming this is the last page. The corner store sells apple at a rate of 125 per apple. Okay, here we go. 125 an apple. Okay. What is the ratio of dollars to apple? Yeah, I should go back and actually see what they mean by this. But this is the ratio. $1.25, you get 1 apple. For every dollar and 25 cents, you get 1 apple. Okay. IKEA is only able to spend $10 on apples. How many apples can she buy? Well, this one is simple enough. You have $10, it's $1.25, so you can just simply divide. Okay, I don't know. I wish they asked something different. Okay. Because over here, there is no relationship with 125 to 10, is there? Let's see. Divide. There is actually. I'm sorry. It's times 8. From 125 to 10 is times 8, so this would be times 8. So for $10, IKEA can get 8 apples. My apologies. Okay. And then let's do it again. The ratio is 125 over 1 apple. And this time around, you want to know what happens when you have $6. Okay. And again, 1 to 125. I think it's 4. 4 4.8. Ugly number. So, is there a direct relationship from here to here? It's times 4.8. Not too happy with this number. Okay, why do they do this? And obviously at the bottom is also would be times 1.8. Okay. Times 4.8. And that would give you 6. Wait. Not 6. 4.8. My apologies. So you multiply top of 1 by 4.8 to get to 6. 125 times 4.8 gets 6, and 1 times 4.8 is 4.8 apples. So you know you can't buy 4.8 apples, but you can buy definitely 4 apples. He doesn't have enough to buy that 5th apple. It's almost 5 apples, but it's not. So how many apples can Christian buy? He can buy 4 apples. Okay, I would have much rather done this way. 1.25, 1 apple. Okay, using a rate table instead. Okay, 2 apples would be 250. 3 apples would be 375. 4 apples would be $5. Okay, this is dollars. This is apples. Okay, and then you would have noticed that for 5 you needed $6.25. Okay, for 5 apples you need $6.25, which obviously is not going to happen because you only have $6. Okay, so the maximum he can buy is 4 apples. Okay, and $5. He doesn't have enough. He has $6, but it would have cost. He needs a quarter more. All right. Hopefully that helped. Okay, and let's see what your clue is. I'll write what I have on my TV screen. Alright, so that's what's playing on my TV right now. Okay, there is your secret word. Alright, that's it. Yeah, that's it. Those of you who are in 601, please go to the other page, which is the post-winter break, and that is where I'll put the answers to this worksheet, the handout. Okay, for the homework today, we didn't go through all the questions, so I'll put the answers there. Okay, I'll just go over there. Okay, and that's it.